Mode, again, is very simple. The mode of a data set is the value or values that occur with the greatest frequency. I have 1, 2, 2, 3, 5, 7. My mode is 2 because that's the number I have the most. All the other ones I just have one of. I could have something that's bimodal. That means if I had 2 3s, then I would have 2 modes because they both have the same amount. Neither one occurs with more frequency than the other. This is called bimodal. The mode can be found with qualitative data. A data set can have no mode, one mode, or multiple modes. They're saying that it doesn't have to be quantitative. Remember, quantitative is numbers. Let's say we put people's names in alphabetical order. We can find the mode. Maybe one of the names is used the most. That would be the mode. It doesn't have to be numeric. There's no numbers necessary. Finding the mode. A data set can have one mode, more than one mode, or no modes. When 2 data values occur with the same greatest frequency, each one is a mode and the data set is said to be bimodal. So that's when you have 2 values that are the same, like we did here. We have 2 and 3 are both the mode. And that would be considered bimodal. When more than 2 data values occur with the same greatest frequency, each is a mode and the data set is said to be multimodal. If I had 1, 1, 2, 2, 3, 3, 4, 5, 6, this would be multimodal because I have 2 1s, I have 2 2s, and I have 2 3s, and they all occur twice. If I had 1, 2, 3, 4, 5, this has no mode because they're all basically once. No data values repeated. This would have no mode. Find the mode. I can show you how to do it on StatCrunch. It's in the exact same place. And I can hit Options, Edit, and I don't really need the median anymore. But what I do need is the mode. That's it. I hit Compute, and now I know that out of the 7 values, 1, 2, 3, 4, 5, 6, 7, my mode is 0.3 because I have 3 of them, and that's the most. I have 2 0.6s, but that's not the most. That's the second most. 0.3 is the most. That's my mode. If I had one more 0.6, it would be bimodal. The data speed in megabits per second of 0.3, 0.6, 0.6, 4.0, and 4.0 have 2 modes because 0.3 occurs twice and 4 occurs twice. And so I have 2 modes. And just as I said before, no mode because there's no value here repeat. Sometimes we need to find the mid-range. If you put everything in order, it's the mean or the average of the 2 extreme ends. And I can find that as well using StatCrunch. The mid-range of a data set is the measure of center, that is the value midway between the maximum and minimum values in the original data set. It is found by adding the maximum value and the minimum value and then dividing by 2. If I go back to StatCrunch, let's use everything from Verizon. If I look here, I don't see mid-range. I have range that's different, but you know what? If I find the maximum and minimum, I can do this myself. I'm going to compute. I have the minimum and I have the maximum. I can add them together. We have 77.8 plus 0.8, which gives me 78.6. And then I divide that number by 2. And that gives me 39.3. And that is my mid-range. I can still use StatCrunch even though I can't get that exact value. It's not hard to take a calculator and add them together and divide by 2. Important properties of the mid-range. Because the mid-range uses only the maximum and minimum values, it is very sensitive to those extremes. The mid-range is not resistant because if my outlier is either too small or too big and all the rest of my numbers are really close together, let's say I have 1, 2, 3, 4, 1,000. This is very obviously an outlier. And my mid-range would be 1,000 plus 1, my max plus my min, divided by 2, which is 500.5. That is very different than if I had a 5 there instead of 1,000. 1,000 is really an extreme outlier, and it changes my mid-range quite a bit. If I had 1, 2, 3, 4, even if I said 10, and I would then use 1 plus 10 divided by 2, which would give me 11 divided by 2, which is 5.5. That is a considerable difference by just changing one value. So we can see that the mid-range is not resistant to outliers. In practice, the mid-range is rarely used, but it has 3 redeeming features. It's easy to compute. We just saw that. The mid-range helps reinforce the very important point that there are several different ways to define the center of a data set. The value of the mid-range is sometimes used incorrectly for the median, so confusion can be reduced by clearly defining the mid-range along with the median. We already did an example, but here, if you put these in order, you'd see that here is my minimum and here is my maximum. So I add those two numbers together and divide by 2, which gives me my mid-range.